lesson on angle relationships. This is very similar to the last lesson. It's just instead of segments, we're going to do angle measures. Okay. So yesterday we did the segment addition postulate. This is angle addition postulate. This just says if I have two smaller angles, so when we add two smaller, and it's not just smaller, but also adjacent angles, that equals the big angle. Okay? So I have two adjacent smaller angles. Have to add up to the big angle. Okay, kind of like what did we say yesterday? We had two small segments, right? So AB plus BC
They have to be
equals
adjacent,
AC.
right?
They have to be adjacent, just like the two segments when we did segment adjacent. They also had to be next to each other. Okay. Good. All right, let's do a proof. And also, if you have those list of reasons that I gave you yesterday, might want to have that. Anytime we do proofs in class, it's helpful to have it. You will also have always a copy of this for every test, okay? Every test that has proofs in it, I should say. Okay, so let's see what we are starting off with. So given, we know measure of angle 1. I'm going to just mark this in my picture. Measure of angle 1 and measure of angle 2 are congruent to each other, or they're equal to each other, actually. Okay. What am I trying to prove? I want to try to prove PXR, okay, this angle, that's kind of 1 and 3 combined. I want to show that that's equal to SXQ, which is 2 and 3 combined. Okay. So can you kind of visualize that? All right.
Oh, so can I say something?
Yeah, go for it.
PXQ plus QXR equals PXR.
Perfect. So you basically said
Measure 1 and 3.
Measure of angle 1 and 3 add up to PXR. That is using what is at the top of the page?
Angle addition.
Good. Angle addition postulate. Works just like the segment addition postulate. Two smaller angles add up to the big one. It doesn't matter if you put measure of angle 1 plus measure of angle 3 first, or if you say that that's equal. All right, SXQ is 2 and 3 added together. It's the same reason, right? So I am saying, right, so what do we notice? Both of the, okay, again, what do we, so some of you, I know the statements are given here, but like, it helps to kind of cover up the paper and kind of figure out, what do you think, if we think along the lines of yesterday, Roz?
You can replace measure of angle 2 with angle with
Yeah,
angle 1.
notice,
Because
we're trying to get these two angles equal. So if we can make what's on the right side look identical, equal, then we've basically done it. So since 1 and 2 are the same, does it matter which one I replace? No, but based on what the statement I gave you, we want to replace angle 1.
Substitution.
Good. Okay.
You get it.
Yeah,
So now that we have measure of angle 1 and 3, both add up to each of these two angles, we can make them equal to each other. Substitution. Okay. Yeah, tissue's over on there.
Wait, angle addition postulate is the same as segment just for angles?
Yep, that's all it is.
Wait, so
Yeah,
say
Maya.
you were trying to find measure of angle, like if measure of angle 1 and measure of angle 2 were congruent to each other, and you had that measure of angle 3 and measure of angle 2 congruent to each other, could you replace the 3 with the 1 for substitution if that's what you're trying to
If that's what we're trying to prove. Okay, little break from the proof. So this is an application to the proof, finding the measure of angle 3. Okay, what do we know? We know measure of angle 1 is 23. So here, this is 23 degrees. Angle 2, we could see there's a little square, so that's 90. Oh, and measure of angle ABC is 131. So that means the whole thing here. So I know 23 plus 90 plus the measure of angle 3 has to be equal to 131.
Did you say X?
Yeah, sure. Yeah, if you want to make that an X instead of measure of angle 3. But we see all three of these, they're all adjacent to each other. So they're all going to add up to that big angle 131. Well, 23 and 90 add up to 113. So then we're going to subtract 113. What do we get for measure of angle 2?
17.
18.
Yeah, I think that's not 17, yeah. Okay.
How is that notes? I mean, I'm not complaining.
What's that?
How I just said, how is that notes? But I'm like, I don't really care. I'm just saying.
Okay. So it's a combination of doing the proofs and also the application to it. So we're just basically looking at, okay, so what do we have next? We have 6 and 7 form a linear pair. That means 6 and 7 have to add up to 180. And then that means 3, 4, and 5. Let's see here. 3 is x plus 20. 4 is x plus 40. And 5 is x plus 30. And then 6 is 3y plus 32. And 7 is 5y plus 12. Now, we don't know anything that's congruent here or angle bisectors. We're 3, 4, and 5 are all going to add up to, good, so we'll have x plus 20 plus x plus 40 plus x plus 30 equals 180. Sure. And then we also know 5y plus 12 plus 3y plus 32 also adds up to 180. Yeah, so yeah, you can, something like that. That's easy enough. If you want to play it safe on a quiz or a test and write it out, because if you make a little careless mistake, I can give you more partial credit. So 3x plus 90.
X equals 3.
3x equals 90, x equals 30. Okay, so that makes angle 3 50. Right. Angle 4 is going to be 40 plus 30 is 70. And lastly, angle 5 is 30 plus 30, 60. We can do a quick check if we were to add those three angles. Does that give us 180? Good. Okay, let's check y. So here we're going to get, let's see, 8y plus 44. Subtract 44, that's going to give us 8y equals 136. And divide that by 8.
17.
Yeah?
Yeah.
Okay. Yeah, this one is a little bit, I wouldn't say harder, just doesn't like, when you have something that ends in a 0, it's much easier to plug in. 5 times 17.
75.
Okay, and then add 12.
No, it's
It's 85.
Wait,
not.
it's 85.
It's 85 plus 12
Is
97.
97?
Yeah.
That's for 7.
Oh, yeah, that's for 7. Sorry, put it over here. And then 3 times 17, 51. 51 plus 32. And double check. These two should also be supplementary. We're good.
No, it's not. Me?
What happened?
Wait. I think yours are back. One of
No?
yours are back. Mine are backwards. Mine are back.
Sorry, when we plugged back in, I plugged it into angle 7 first, and
Okay,
I
okay.
put that over
I was
here,
very
and then
disoriented.
sorry, I plugged it in the way the picture looks,
Yeah.
like left to right,
Yeah.
but then my
That's okay.
answers were
I
there.
had backwards.
Jason?
yes,
Right now.
yeah. You want to just take the
You tell me. Yeah, sure. What did I take?
nothing, a pencil.
Didn't we get calculated?
Oh yeah, you know what? You're right. Zoe convinced us all to
I needed that.
let me.
But that
I
was-
let. It was supposed to be no calculator, and then I let.
I need a calculator.
Not really.
Am I like really calculator? It's like it's a little bit helpful.
It's a teeny tiny little bit helpful in the first one, and that's about it.
Do I take a desk out?
Okay, let's look at supplement theorem. This is actually a review. Oh, yes.
I have a question.
Sure.
Like numbers 2 and 3 that we just did, like what are they?
Oh,
No,
It's-
take quiz.
an application to the angle addition postulate. So angle addition is when we add angles
Don't
and
really
we
leave
get.
us open or closed.
You can close it. So what did we do here? We added these 3 angles equal to the big angle.
Okay.
Here, we added these 3 angles equal to 180. We added these 2 angles equal to 180. Angle addition is just adding adjacent angles
Yeah.
equal to a big angle. Okay? All right, now supplement theorem. This is a revisit. Supplement theorem, also on that sheet, just says if we have a linear pair, we have supplementary angles. So if angle 1 and 2 form a linear pair, I know they're supplementary. If they're supplementary, then I know they add up to 180. Complement theorem. Again, we did this one already. We're just going to start using it in proofs. If we have adjacent angles that form a right angle, then the angles are complementary. Okay, so if we have 2 angles that are adjacent and form a right angle, they are complementary. If they're complementary, then we can say they equal 90 degrees. Okay. Again, this is just a quick summary. We already know reflexive, symmetric, transitive. I just kind of threw this in here. Those properties all apply to angle congruence. Good. All right. This is a new one. Congruent supplements theorem. Okay. Angles supplementary to the same angle or congruent angles are congruent. Okay. Let's take a look.
Wait, what?
Okay.
Wait, a theorem is you prove, yeah.
Yeah, we're going to prove these.
Okay.
Okay. And then
Oh,
we're going to prove the congruent complements theorem. For the first one, I'm just going to summarize what we're saying here. So take a look at this picture. Let's say measure of angle 1 and measure of angle 2 equal 180 degrees. So kind of just ignore angle 3 for right now. Does that look about right? Angle 1 and angle 2, they look like they add up to 180. Okay. Now what if I ignore angle 1? What if angle 3 and angle 2, or 2 and 3, also add up to 180?
That means that angle 1 and 3.
That means, well, hold on. What does that?
They're
Oh,
congruent.
yeah,
1 and 3 are congruent.
That means angle 1 and 3 have to be the same.
For this, we don't have to write the measure 1 and 3, whatever.
What's
I get this, but when would I ever need to use that?
Oh, okay. So you don't.
What? So why are we learning it?
It's a shortcut. Okay? So why do we learn all these different theorems? It makes your proof shorter and shorter. If you're one that likes to get through things with shortcuts and abbreviations, just by the way, that little ... that actually is a math symbol, and it stands for therefore. This is kind of a proof of it. We kind of did a proof without any reasons. So here we had two pairs of angles that are supplementary. So then I know angle 1 and angle 3. Now I didn't do the whole proof, but if you were to do this in a proof form, well, they're both equal to 180. So could we say angle 1 plus 2 equals 3 and 2 added together? Yeah. And then you can subtract angle 2 from both sides. And you get angle 1 equals
So this one actually is like this one you would use a lot.
This one we would use a lot. Now, if I were to do this as a proof, which we're gonna prove at the bottom of the page, we're gonna do the congruence complements theorem. You don't have to ever use this theorem. Your proof's gonna be about 4 or 5 steps longer. Yeah. So if you can do the shortcut, your proof will be much shorter. That's why if you can see, right, what do we have here? We have angles supplementary to the same angle or congruent angles. Our conclusion is that they will be congruent to each other. So if I have angle 1 and 2 are supplementary and 2 and 3 are supplementary, what's my conclusion? 1 and 3 have to be congruent. Okay, so here I kind of just put it in symbols. All right, questions? Yes, Jade.
So, like, if we did this on a proof, are we just skipping the substitution and
Yeah,
subtraction?
we're skipping all of that.
And we don't have to do this.
Right. So you're going to have a list. You have this congruent supplements theorem. It's towards the bottom of the page because this is one of the last things we'll learn in this chapter. You can use it on any proof, okay? But you don't have to. You can go through the process of proving the theorem within another theorem. You see what I'm saying? It's like, or you can jump right to the conclusion. Yes, Leah.
So it skips the substitution and then subtraction, right?
Exactly. Okay. Congruent complements theorem. Angles complementary to the same angle or congruent angles are congruent. So this is saying, okay, what if I have 4 and 5 add up to 90? And then I say, oh, angle 6 and angle 5 also add up to 90. What's my conclusion going to be? It's going to be 4 has to be equal to measure of angle 6. Or angle 4 congruent to angle 6.
For the counter example, can I draw?
He can draw. I don't know how neatly he can draw.
Why?
Oh, I was recording.
Why did we put the measure of angle 4 equals the measure of angle 6 and above we put the
Oh.
congruent?
I did both. Oh, I could do therefore measure of angle 4. Or sorry, angle 4. The only reason I did this is what does the theorem actually state? It states that the angles are congruent. So you're going to see, you see what I did here? We're going to do something similar. We're actually going to prove that theorem, but we're going to go through each and every step this time.
So,
I have a really quick question. Does this one have to be at the end, or can it be in between? Like.
Oh. Does it say between anywhere?
No.
Oh, I forgot to tell you. There was a hint.
yeah.
One's true, one's false.
Yeah, that's what I thought.
That's what he thought.
I have a question.
Yes.
So, does the measure of if you write measure of angle 4 equals measure of angle 6, is that the same thing as writing angle 4 is congruent to angle 6?
Wait, I have a question.
So then what? Why? I don't get it. Then do you use which one?
Okay. If you're using the
It's
theorem,
asking
you're going to
for
say
the-
congruent. But watch what we're going to do in this proof here.
Oh, I have a question.
Yes.
So, in the congruent supplements theorem and the
Congruent complements theorem?
So, I know we're going to do it right now, but if I would do this work and I would put it in like the statements pile,
Yeah.
for the reasons, my only reasons would be given and then.
Congruent complements theorem. Okay.
But how
So
do
I
know-
can't use the theorem to prove the theorem. Otherwise, this theorem would be 2 steps long.
Yeah, that's what it's.
Okay. So what ends up happening, and this is what we, listen, this is part of being in the honors geometry versus at level. We do prove most of the theorems that we use. Whereas the at-level geometry, they don't prove nearly as many theorems.
How do you prove a theorem?
Well, that's what we're about ready to do.
Did I do it wrong?
I don't know.
I just proved it.
Okay, again, you can't prove a theorem in 2 steps because then you can't use the theorem to prove the theorem.
Oh, I used
You have to explain it.
You have to explain it. I should not have congruent complements theorem anywhere in my reasoning here. Okay? So let's start with, what does complementary, what's the definition of complementary? Okay, so I'm going to say measure of angle 1 plus measure of angle 3 equals 90 degrees. And I'm going to say measure of angle 2 plus measure of angle 3 equals 90 degrees. Okay, because look at what is given. I can only go based on what is given.
So for this
And
one,
this is definition of what kind of angles? Complementary.
For this one, you'd have to do the substitution and subtraction to like. prove
Yeah,
the
yeah.
theorem.
Okay.
when would you not?
If you're not proving the theorem, you're just proving
So,
that you're not.
yeah.
Measure of angle 1 plus measure of angle 3 plus measure of angle 2. Wait, no.
Okay, so there was a question, when do I ever need the congruent complements theorem? You don't. You could always do this proof within another proof. But the idea is to use the shortcut. So let's see if we could get through some more of these examples. Remember all tomorrow is going to be proof review. Okay, so if we're having trouble with the proofs, all tomorrow is going to be extra practice. Okay, what do we notice is the same here? The 90. Also the angle 3. But if they're both equal to 90, what can I say about measure of angle 1 and measure? Go ahead, Mia.
Measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3.
Perfect. So that's going to be
So that's gonna be substitution.
good.
And then you do subtraction.
Good. Again, keep your eyes on the goal. My goal is to get angle 1 congruent to angle 2. So we want to try to see what can we do to isolate. Now I got those measures in there. So sorry, I didn't give you a lot of room here. Measure of angle 1 equals measure of angle 2. That is subtraction. Remember I told you if it's substitution or subtraction to make sure you put that 4th letter. And then we just want to translate that back into a congruent sign. And so yesterday we did definition of congruent segments. This will just be definition of congruent. Oh, and you'll notice you could just use an angle with an S if you want to abbreviate angles. So that was 5 steps. If you don't want to have an extra 5 steps in your proof, just use the theorem. Okay, so let's look at proving vertical angles theorem next. All right, so I know angle 1 and angle 2 form a linear pair. And I know 2 and angle 3 form a linear pair. You can abbreviate in your notes, it's fine. Now, I'm going to have you look at the geometry proofs list. Is there anything on here that says linear pair? No. Okay, but we did do a theorem that had to do with a linear pair.
It's like the supplementary.
Okay, I'm going to go back.
Definition of supplementary.
What's the supplement theorem? So if 2 angles form a linear pair, what is my conclusion? What can I say about those 2 angles?
180.
Okay, that they're supplementary. Okay. Here we go. So I'm going to say, angle 1 and angle 2 are supplementary. Remember, what did the theorem say? It said they were supplementary.
Oh, so you can't say equal 180?
That would be, okay, if I said they were equal to 180, that would be definition of supplementary angles. This is where the proofs can be a little tricky. This is the supplement theorem. The supplement theorem says if I have linear pairs, we can say that those angles are then supplementary.
So,
Okay, now there's a very long way to do this, or I can be done in 3 steps. Do I have 2 angles that are supplementary to the same angle?
Yeah, so 1 and 3.
So one is congruent to 3.
It's so much easier.
This,
how do you already?
so we just used the congruent supplements theorem. Okay, so Sammy, you don't want to use that? You could do angle 1 plus angle 2 equals 180. Angle 2 plus angle 3 equals 180.
Wait,
Then you could
supplement
say
theorem is
there's,
what we
then
did
you could go through and say they're equal to each other. Then you can do subtraction, and then you can translate it back over into congruent. Your proof would be 4 steps longer. But if I know what congruent supplements theorem, I'm like, oh,
The angle.
angle 2 and angle 2. They're both supplementary to angle 2. So that means angle 1 has to be congruent to angle 3. So my proof is only 3 steps.
Logic.
Yeah. It's a shortcut. So the better you know the theorems, again, making flashcards is really helpful, the shorter your proofs are going to be. How are we doing?
Does anyone have flashcards like on Quizlet?
Oh, Quizlet's good too. Okay.
Is this every single one, or is this still in some of their ones?
What's that?
Are these all the ones still in case we just look at them to be there, or will there be more?
These are the ones we know for chapter 2. Each chapter we're just going to add a little bit more. So if you do, these are for so you have to figure though, that's not that bad. This is already chapters 1 and 2 combined.
That's a lot.
Yeah, but how many of them?
How many are they total?
Yeah, a
Like,
lot.
like enough to fit a page?
400.
Yeah.
400?
No, not 400. No, I said page and a half. Yeah.
We're not even
That's like
halfway.
for the whole year though.
We're-
Okay.
We're probably like
Not even a quarter.
Are we gonna memorize all of those by the end of the year?
Again, you don't need to remember the names. I'll always give you that sheet of paper. You
So
just
you know
need
what
to
they-
know.
you
You need to know what they
Oh,
mean.
We're gonna have this on the test.
What about the
Okay.
final?
Okay. Definition of perpendicular lines. Let's just review that. Those are angles, or sorry, those are lines that form right angles. Okay, here is my theorem. All right angles are congruent. So I'm going to now prove that. I want to prove if I have parallel lines, I want to prove the angles are congruent. Okay. Right. Again, some of these theorems are duh. Of course that's true. But I want to be able to prove that. Okay, so in other words, I am giving you AB segment or line, it doesn't really matter, is perpendicular to CD. Okay, what am I trying to prove? I'm trying to get AEC and BEC congruent to each other. Yeah.
So, could we say measure of angle AB plus measure of angle CD? Wait,
No,
Oh, wait, no, no,
AE
no.
plus EB.
Okay, hold on. What do perpendicular lines form?
Line.
yeah, that's what I was trying to get to. But
Okay.
It's one right angle.
Okay, definitions say they form right angles. What I need you to do is tell me which ones are the right angles.
Could we say?
Which ones am I trying to prove?
Oh, AEC and BEC.
Could we say E is the midpoint?
Yeah,
Oh wait, what if it isn't?
just a second, Sammy.
Wait, what? We could just say that?
Yeah, look at the definition. Look at the definition here. What were we given? We were given perpendicular lines. What is the conclusion I can make? What's they form right angles. What right angles am I trying to prove congruent? These two. Now, could I have said this is a right angle, this is a right angle, this is a right angle, and this is a right angle? Yes. Okay, I just didn't list all 4 angles because I'm only working with 2 of them. Okay, but if I wanted to say all 4 of those were right angles, great. Now, there's a reason I only listed the 2 because those are the only ones that we're proving. Okay.
So just make it congruent
Okay, well, hold on. How do we know they're congruent?
because they're both definitions.
Okay, but that,
They both
You're
equal
all
90.
they both equal 90. Okay, that's my next step. So I'm going to say step 3, I want to say measure of angle AEC equals 90 and measure of angle BEC equals 90. Definition of, what did I call them? I called them right angles. Do you see each time I go back and I look at what were the words or math symbols that were used directly above, right? That's going to be my reason. So here, perpendicular, that was my justification in the second step. Right angles, that's my justification in the following step. Definition of right angles. Okay, now that they're both equal to 90, substitution, I can say measure of angle AEC. Substitution. And last, good. Now I'm going to just translate that into congruent. So it's going to be angle AEC congruent to angle BEC. These are definition of congruent angles.